You're hanging with Hussick again. This time we're going to be writing ionic equations and looking at how to write a chemical equation in 3 ways that can help communicate and model what's happening when you combine salts. Okay, so a question prompt might say something like the following. Aqueous strontium hydroxide is mixed with aqueous silver nitrate. Write the formula equation, the ionic equation, and the net ionic equation to represent what happens, okay? So, first of all, we'll work on writing what they call the formula equation. This means you write out the formulas for the starting compounds, and then you figure out what the products are and write the formulas for those. Usually, this is going to represent what we call a double displacement or a double replacement, depending on who you talk to, reaction. Okay, double replacement, they're sometimes also called. Okay, so that's going to be, that's what kind of reaction it is. All right, so we need the actual formulas. The formula for strontium hydroxide. Strontium is a 2+, so it's going to look like this. It's going to be SR. The hydroxide is a -1, so you need 2 of them. Okay, and it's aqueous. And then we're going to add to that silver nitrate. Silver is a +1, and nitrate is a -1, so they're going to go together like that. And then the products they're going to make, whenever it's a double displacement or a double replacement, they basically swap anion for cation. So we're going to have strontium nitrate here. So we'll need 2 nitrates for that. There we go. And that would be aqueous. And if you weren't sure, of course, you know, why, I don't expect you to know this off the top of your head, but how do you know strontium nitrate's aqueous and it's not going to precipitate? Okay, that's a really important thing to check. So you have to check the list, check the table of solubilities. Okay, and what you'll see if you check the table of solubilities in the data book, you're going to see that basically any nitrate compound is soluble. Okay, so this is going to be aqueous, and then the other product that it produces is going to be silver hydroxide. And silver hydroxide is a solid. Silver hydroxide is not soluble. Okay, and again, you would check that on the list, and you'll see that hydroxide has a low solubility when mixed with a silver ion. So silver hydroxide is an insoluble product. Next, just double check that the reaction is balanced, that the equation is balanced, okay? And what you'll see is that, well, we got 2 nitrates over here on the right-hand side, see? So we need 2 over here as well. So then we put a 2 on the silver, so let's put a 2 on the silver there, and that fixes the hydroxide problem, okay? So that is now the balanced formula equation for this reaction. So maybe I'll write that there. There's an arrow, but we'll put it there anyways. This is the formula equation. Okay? Next, it says to write the ionic equation. Well, when you're writing an ionic equation, you're just writing out everything as ions. And we know that since all of these are ionic compounds, they're essentially all going to exist as ions. The exception for the one you don't write as ions is the one that stays together as a solid. Okay, so that would be the silver hydroxide. So we're going to write all the aqueous compounds as ions. Write all aqueous, I couldn't decide what I was doing there, aqueous compounds. I'm trying to make this a little clearer. Write all the aqueous compounds as ions. Because what this is going to lead to is it's going to lead to us being able to eliminate ones that aren't really important in the reaction. And that's going to be called the net ionic. So, okay, so this is the ionic equation going down this way. Okay, trying to make a little arrow there. That's your ionic equation. So we'll just write strontium 2+, aqueous. This takes up the most space, by the way. There's 2 hydroxide ions. that are aqueous. We're writing them out. There's 2 Ag plus silver ions that are aqueous. Writing that out. There's 2 nitrate ions that are aqueous. Okay, on that side. And then over here we have the strontium 2 plus ion. We have 2 nitrate ions again that are aqueous. Okay, and then we have the silver hydroxide solid, which we do not write out in ionic form because it's a solid rather than being aqueous. Okay, so then if we look at this, this is called the Ionic equation. Okay, I'll put this here. This is the Ionic equation. Or sometimes it's called like the total ionic equation or the gross ionic equation, whatever. And you're like, yeah, it's gross, all right. Okay, what we do is we look at the last bit here, making the net ionic equation. Okay, what happens in the net ionic equation is we cancel out ions that are the same on both sides. Okay. Same on both sides. And what these are actually referred to as ions that are the same on both sides are called spectator ions. A spectator ion doesn't really participate in a chemical reaction. So if you look at this, I'm going to cross these out in green in the reaction ahead, and we're going to get to the net ionic equation here. There we go. So strontium is there as strontium 2 plus on the left, and it's there as strontium 2 plus on the right, so we cancel it. Silver becomes part of the solid, hydroxide becomes part of the solid, but the nitrates, the 2 NO3 minus, are there on the left. They're exactly the same on the right, so we cancel them out. So these things that are redundant on each side are called spectator ions, and then we'll write the net ionic equation. So this is going to be the net ionic equation. It only contains the ions and the compounds that are changing their identity completely. So that's going to be the 2 hydroxide aqueous and the 2 Ag plus ions turning into Ag hydroxide. Now, an excellent question someone mentioned in class is like, wait a minute, now they all have 2's as prefixes, as coefficients, rather. Do we need those 2's on there? No, you don't. You don't need them anymore. So you can actually just knock those off. Okay, it's unconventional to have them in there at this point. Okay, so that's the net ionic equation. And if you want to look at what reaction ultimately happened when you mixed aqueous strontium hydroxide with aqueous silver nitrate, this is the reaction that ultimately happened. The aqueous hydroxide ions and the aqueous silver ions combined and precipitated silver hydroxide, an insoluble salt. So I hope that helps you learn about the 3 different types of equations and how you can use them in these type of solubility problems.